Okay, carrying on. So next question with this tennis ball business. Calculate the height, the maximum height it actually reaches above the ground when this tennis ball is launched. So we know a whole heap of things about this tennis ball, but if we're thinking about this height above the ground, we again have to think vertically. So we knew what its initial vertical speed was. It was 4.34 from previous questions. We had to calculate that. We know that when it's at its maximum height above the ground, that its velocity there will be 0. And again, we know what acceleration is. It's negative 9.8. So we could say, okay, well, what's the distance that ball is going to travel with these parameters? You'll notice that I haven't put time down. We calculated time in the previous question. But, I mean, I always like to use the information I'm given in the question because that is definitely the right figure. So if you calculated time in the previous question, you could use time here, and you could use any kinematic equation you like. But if you've made a mistake or you have rounding, then that's going to come out in your working as well. So we need to find an appropriate kinematic equation. We need to find the one that does not have t in it. So it's going to be, I believe, this plus 2 AD. And again, we're going to just substitute our numbers in and solve for d. So VF squared is 0 squared. That's convenient. 4.34 squared plus 2 times a, so I'm just going to do that straight away, is going to be 19.6, but negative, so you could just change that to a negative 0.6d, because that was just 2a there. Because acceleration is negative, just makes it a negative. So let's solve for that. That's obviously 0. 4.34 squared is 18.8. So if I take that over, 18.8. So again, we'll cancel that by dividing it on the other side. So distance equals 0.961 meters. But think about that. That is how far the ball has traveled vertically from where it has launched. Okay, so this distance here is 0.98. The ball was originally launched 3 meters above the ground. Oh, so this is not actually the answer. So the actual maximum height above the ground is going to be 3.961. Probably 3.96 because we had things to 2 significant figures. Then it wouldn't be 3.96. It'd be probably just 4.0 if we had 2 significant figures. I'm just going to leave it like that because I like it that way. So yeah, you'd round it appropriately. I believe all the information we did get was in 2 sig figs. So yeah, that would round to, what, 4.0 meters. Yay, we're getting there. We'll get to some of the trickier steps coming up.